Many hackers at StarTech asked us how we built the digital twin. So here is how. First, let's take a look at it, what it actually is. We needed this greenhouse on Mars, which is totally 3D rendered, and it needed to be interactive. So we were able to click on plants, we can see their states, we were able to click on modifiers, and we can actually control them and things are happening. So this was the requirement. We needed to build a 3D environment which was interactive. As you can see here, we have built some 3D experiences before. The tech stack we've leveraged here is Blender for modeling the whole scene, and then Three.js for visualizing it and actually running animations and stuff like this, and controlling it, like the controls so I can navigate and zoom in and stuff like this. One lucky thing is that a friend of mine, Yannick, actually just a few days before StarTech showed me that he has a Blender MCP server, so Cursor was able to build a Blender scene by itself, and it was actually pretty impressive to me, so I knew I had to give it a shot. This was at the very beginning of the hackathon, where we were still heavy in exploration phase. We quickly learned that there was this Blender MCP server, which Yannick talked about, and we tried to build scenes with it and actually render them to see how it's working. So we can see it was able to render just a sphere. We tried to go very iteratively about everything. So we just rendered a sphere and tried to render it so we can see it. And then we tried to render a tree, and then from there we got more in the direction that we needed. So we tried to render a plant, and then we put it in a little greenhouse, and so on. So we quickly learned that it can actually build a full greenhouse in Blender, as you can see here. This was in Blender, built by Codex, and rendered as a PNG, so we're able to see it here. And this was already way better than we expected at all, since we wanted this low poly style, which is the easiest to build quickly. This was already really good, and we didn't expect it at all that we can get this far. But one thing we knew is we need to get this into Three.js so we can actually make it interactive and connected. So this was the biggest pain point we identified with using this approach, because how we did it before with our other things that we've built is we built everything manually in Blender, labeled the objects and everything by ourselves, and then in Three.js we were able to identify the objects again by hand to then control them. So we had no clue how Codex actually built the scene and how we could connect it on Three.js. So this was the problem we have identified at this point. So we took this learning that Codex and Cursor already can handle Blender super well, but we had the problem of getting the Blender scene into the website. So we just tried Three.js. And maybe a quick overview on the tech stack first. So Three.js is the JavaScript abstraction of WebGL, and WebGL allows to render 3D scenes and shaders and all of those things in the web, but it's very complicated. So Three.js is just an easier abstraction on it, which I like to use. And React 3 Fiber is another thing that works with Three.js, which allows you to define in React components as you know it from React, but then they are Three.js objects. So you can actually manipulate and render them as they were React, but they are Three.js behind the scenes. And Cursor was able to handle this pretty well. So what we did is we set up Three.js and React 3 Fiber in our hack repo, and we again went on this very iteratively. So the first thing was just a simple cube with a light and orbit controls. Orbit controls is that you can, with the mouse, navigate around your scene from wherever you want to look at it. And this worked immediately out of the box. And we were pretty impressed because it took us hours to build things like this before, all the time. So we actually just continued iteratively with it. And I can actually show you on the live app that we have on our greenhouse, we actually have an endpoint / plants. And this was the very early stage. So we didn't begin just build me a greenhouse. We first started with the plants themselves. So what you can see is each plant has 4 different states. It's the seed, then it's growing and harvesting, and whatever this state is called. And we've built 3 different plants because that's all we needed for our case and our demo. And you can see here, this is what orbit controls are. So you can just like scroll around the scene. And we've built this for all 3 plants. So we didn't want to go for perfection just yet, but we needed to do it iteratively. If we just told it to build a greenhouse, it might have worked, but we didn't want to gamble on it. So we just tried to first iterate on the plants and then continue from there. And I can also quickly show you how this looks like in the code. So we have this greenhouse scene where you render the canvas and the whole Three.js thing. And then in there we have this component. So we have the Mars backdrop, the intro camera rig, the Mars intro FX, the lights and so on. But these all were added later. The first thing we did was just shelves, or even a step before, as I've shown before, the plants themselves. And then we tried to put them on shelves. And here we have, again, just React components. So on the shelves, we also then later added the shelf wall fan, which we didn't have in the beginning. A shelf was just an array of layers, basically. So we had the layers, and on the layers, it was just a grid of plants with some fancy effects, of course, with the watering system and so on. But in the beginning, it was just a grid of plants. So what you can see here is it's just this plant component. And on this plant component, we then map it to the type of plant that we have and the stage that it is in. So this is now exactly what I've shown you here before. We have this lettuce plant down here. We have the potato and the soybeans. So this is exactly the mapping that we've done here. So you can see we ask it for the plant type and then render a different component, just like you would in React. I mean, it is React. And then down here in potato plant, for example, then we actually have the pot, which is for all plants the same. So this little pot thing in the bottom, it's the same for all of them. And then what we have is with the different stages, we just render different kind of components from Three.js. So that's how we connected the whole React things and the Three.js thing. And like Cursor really did all of it. So it was extremely impressive to us that it can just build 3D environments, make them interactive and so on, just all by itself. And literally what we did is we just told it, set up React 3 Fiber and Three.js, and then we just worked iteratively with it. So we just told it, okay, first start by just rendering a cube with orbit controls. And then from there, we told it to first, please just build the plants out. And then we continued with the whole shelves, the layers and so on. Then we started building the greenhouse around it and then the whole Mars environment. And at the end, the whole intro animation. And like this, we were able to basically skip all the Blender stuff, which we probably wouldn't have time to in the hackathon to build all of it. And we just gave AI the full control on everything, and we just nudged it into the right direction. So if you have any more question about how to build those 3D experiences on the web, feel free to reach out to me. But the agent skills that you can find on React 3 Fiber and Three.js are definitely worth checking out. And also just getting into Three.js and its basics will definitely help on steering Cursor or Codex or whatever you use in the right direction.